Good morning, everyone. Welcome back. Today, I'm going to start a new chapter. The name of the chapter is Trigonometrical Identities. It's easier. Again, the chapter itself is based on formulae, formula based, and it's very, very important for higher studies. When you take up science, you need to do this trigonometry in elaborated form, in vast form. So please do watch the video till the end and understand the concept involved. Trigonometry is the branch of mathematics which deals with the measurement of angles and sides of a right angle triangle. If you recall your class 9 maths, you have done trigonometrical ratios of standard angles and trigonometrical ratios of complementary angles. There are 3 exercises in class 9. In class 10, same chapter, trigonometry is modified and the name is given as Trigonometrical Identities. And the chapter itself is based on formulae. Each and every sum has different method to solve it. We know the relation between all trigonometrical ratios, and the first relation is known as reciprocal relation. Reciprocal relation. The first trigonometrical ratio is sine. Sine theta is equal to 1 divided by cosec theta. They are reciprocal to each other, sine and cosec. Since sine is reciprocal of cosec, so cosec will be reciprocal of sine. Cosec theta is equal to 1 upon sine theta. First reciprocal relation. Second one is cos. Cos theta is 1 upon sec theta. Sec theta. Reciprocal relation between cos and sec. Similarly, we can write sec theta is equal to 1 upon cos theta. Third reciprocal relation. Tan theta is equal to 1 upon cot theta. So similarly, we can write cot theta is equal to 1 upon tan theta. These are 3 reciprocal relations, and you need to write these formulae in your formula book and memorize it. Second one is called quotient relation. Quotient relation. First one, tan theta is equal to sine theta divided by cos theta. First quotient relation. Second one is cot. Cot theta is equal to cos theta divided by sine theta. Reciprocal relation, quotient relation. Now we have identities. Identities means square relations. You write identity or you write square relations. First one. There is square relation between sine and cos. Sine square theta plus cos square theta is equal to 1. Addition of square of sine and square of cos is always equal to 1. From this given identity relation or square relation, we can derive 2 more relations. Cos square theta is equal to 1 minus sine square theta. And this formula, this identity is used vice versa. when you have 1 minus sine square theta, you can write cos square theta, or when you have cos square theta, you can write 1 minus sine square theta, vice versa application. Sine square theta is equal to 1 minus cos square theta. Two more formulae are derived from square relation. Second square relation is between sec and tan. Sec square theta minus tan square theta is equal to 1. Sec square theta is equal to 1 plus tan square theta. And similarly, tan square theta is equal to sec square theta minus 1. Second square relation or identity. Third one is cosec square theta minus cos square theta is equal to 1. So we write cosec square theta is equal to 1 plus cos square theta. And the last relation is cos square theta. Cos square theta is equal to cosec square theta minus 1. These are square relations plus relation between sine and cos. Sec and tan, there is minus relation. Cosec and cot, there is again minus relation. So you need to memorize these. And if you know these formulae, you can easily solve the sum. And it's easy chapter, but you need to understand where and what formulae to apply. Apart from these trigonometrical identities or trigonometrical formulae, you need to learn some algebraic formulae as well. The first one is a plus b whole square, a squared plus b squared plus 2ab. Second one is a minus b whole square, which is equal to a squared plus b squared minus 2ab. Third one, a squared minus b squared is equal to a plus b, a minus b. And this formula is frequently used in identities, trigonometrical identities. Third relation, a plus b whole cube. It is a cube plus b cube plus 3ab, a plus b. This is fourth one. Now fifth one, a minus b whole cube, a cube minus b cube minus 3ab, a minus b. Sixth one, a cube plus b cube, a plus b, a squared minus ab plus a squared minus ab plus b squared. And the last one, a cube minus b cube is equal to a minus b, a squared minus plus ab plus b squared. These are algebraic formulae, and you will be needing all these when you solve sums based on trigonometrical identities. And I told you trigonometry is the branch of mathematics which deals with the measurement of angles and sides of a right angle triangle. So these are the formulae. You need to memorize it. And when you solve the sums, keep your formula notebook at the side and start solving the sum and refer the formula book, which formula is applicable. And once you get used to of the formulae, you can do it on your own. It's not difficult. It is exercise 18 from the book. You don't have to do question number 1, 2, 3, 4, 5, 6, 7. These are all introduction and it is related to class 9. So you will be asked only from 8 onwards, and mostly sums are asked to prove, and you will be getting one question in section B for 3 marks. I'll do one question and I'll give you similar sum as homework so you can practice. The more you practice this exercise, easier it becomes. First one is prove that sec A plus tan A 1 minus sin A is equal to cos A. A is acute angle. Acute angle can be represented with the help of theta, or you can represent with AB, any letter. So look at the proving part. You need to be very, very attentive. There are so many different methods by which we can prove it. So choose the simple one and practice. Left hand side, sec A plus tan A 1 minus sin A. You need to simplify this left hand side to prove cos A. So what do? We have sec and tan. These can be changed. So sec we are changing using reciprocal relation. Sec can be written as 1 upon cos A. And this tan can be written as sine divides by cos, quotient relation, 1 minus sine A. When you look at fractions, fractions are simplified by taking LCM. You write cos A, 1 plus sine A. 1 minus sine A is written as you have in the question. Numerator you multiply, 1 plus sine A, 1 minus sine A, keep inside bracket, whole thing divides by cos A. If you look at numerator, one is positive term, another one is negative term, and it is application of algebraic formula here. Suppose if you have A plus B, another term is A minus B, we can use formula and write A square minus B square. So similar formula is applied at numerator. 1 plus sine A, 1 minus sine A can be written as 1 minus sine square A, because square of 1 is 1. Denominator you write as it is cos A. Once you reach this 1 minus sine square A, you need to look at identity. 1 minus sine square A can be written as cos square A. And as I told you, formula can be used vice versa. Divides by cos A. Square means there are 2 cos A. Denominator you have cos A, you cancel this. You are left with cos A. Therefore, left hand side is equal to right hand side proved. Look at the sum. Sec changes to cos, tan changes to sine by cos, LCM. There are only 2 places where we use identity or trigonometrical formula. First one, we change it and we use here and out here. In 3 steps, we are using trigonometrical identities. In other steps, it is just simplification. I'll give you similar sum. Same method you have to use. Please do solve this question. Cosec A, cot A, 1 minus cos A is equal to sin A. You need to prove this. Similar steps are involved. Cosec will change to 1 upon sin, cot, cos upon sin, take LCM, then use identity at the end. Question number 9. 1. It says that prove tan A plus cot A equal to sec A into cosec A. Look at this one. We take left hand side again, copy the left hand side, use quotient relation. Tan can be written as sin A divided by cos A. Cot can be written as cos A divided by sin A. You see fractions. Fractions are simplified by taking LCM. Copy denominators, cos A into sin A. And when you take LCM of trigonometrical ratios, copy the denominator. Now numerator of first multiplies with denominator of second. These two multiplies. You get sin square A plus denominator of first multiplies with numerator of second. You get cos square A. After this we use identity. Sin square A plus cos square A is 1. 1 divided by cos A sin A. On the right hand side you are asked to prove sec and cosec. 1 you write as it is. Cos can be written as 1 upon sec. Sin can be written as 1 upon cosec. Now reciprocate it. 1 into, you get sec A into cosec A, which is equal to sec A into cosec A. Left hand side is equal to right hand side proved. Application of formulae here. Application of formulae here. Again application of formulae. Look at question number 9. Part 2. 1 minus cos A. 1 plus sec A. You need to prove this one equals to tan A into sin A. Similar question. Copy the left hand side. And when you write the left hand side, 1 minus cos A is written as it is. 1 plus, change this, 1 upon cos A. 1 minus cos A. Take LCM. Cos A. You get cos A plus 1. 1 minus cos A at numerator. Arrange this. 1 plus cos A. Denominator you write cos A. A minus B based on the formula 1 minus cos A, 1 plus cos A. If you see like terms with minus and plus, similar terms with minus and plus, use algebraic formula 1 minus cos square A divides by cos A. And after this identity, 1 minus cos square A can be written as sin square A divides by cos A. Now look at the proving part. Sin square A means you write twice. Sin square A can be written as sin A into sin A divides by cos A. Now divide individually. Sin A divides by cos A multiplied by sin A. Sin divides by cos can be written as tan A into sin A. Left hand side is equal to right hand side. Proved. Similar question for homework. 1 minus sin A 1 plus cosec A equal to cot A into cos A. Please do this question. I have given you 2 sums as homework. It's important exercise chapter and you need to apply identities, the formulae which I gave. Formulas are there in the book also, you can refer the book. Please do memorize it. Thank you very much. Stay safe.